Have you ever looked up at the night sky and felt a sense of wonder? The stars twinkle like tiny diamonds scattered across a vast, dark velvet cloth. It's a breathtaking sight, one that has inspired poets, artists, and scientists for centuries. We see countless points of light, each one a distant sun, many with their own planets orbiting them. In this immense cosmic ocean, our own world is just a tiny island. From far away, it doesn't look like much. It is a small, almost insignificant speck suspended in the great darkness of space. But this tiny speck is everything to us. It is our home, our beginning, and our future. Imagine floating in space, looking back at our planet. You would see a beautiful blue marble, swirled with white clouds and patches of green and brown. It shines with a gentle light, a beacon of life in the silent emptiness. This view changes your perspective forever. It makes you realize how small we are, yet how connected we are to this single, fragile world. What makes Earth so different from the other worlds we see? It is the one thing that, as far as we know, exists nowhere else: life. Our planet is teeming with it, in every corner, from the deepest oceans to the highest mountains. Life is in the air we breathe, the water we drink, and the soil beneath our feet. It is a symphony of countless species, all interconnected in a delicate and beautiful dance. Think about the planets closest to us. Mars, the red planet, is a cold, dusty desert with a thin atmosphere. It may have once had water, but today it is a desolate and sterile landscape. Venus, on the other hand, is a scorching hellscape. Its thick, toxic atmosphere traps heat, making its surface hot enough to melt lead. These worlds are our neighbors, yet they are profoundly hostile to life as we know it. A planet needs to be just the right distance from its star, have the right size, and possess the right chemical ingredients. Our Earth is in what scientists call the Goldilocks zone. It is not too hot and not too cold, but just right for liquid water to exist on its surface. Water is the essential ingredient for life, the solvent where the complex chemistry of biology can happen. Our planet also has a protective magnetic field, which shields us from harmful solar radiation. All of these factors had to come together in perfect harmony. In 1990, a spacecraft called Voyager 1 was nearing the edge of our solar system. It had completed its grand tour of the outer planets, sending back breathtaking images of Jupiter, Saturn, Uranus, and Neptune. But before it journeyed into the vast emptiness of interstellar space, the astronomer Carl Sagan had a special request. He asked NASA to turn Voyager's camera around one last time. He wanted it to take a final picture of its home, our planet, from a record-breaking distance. The resulting image was not spectacular in the way a close-up of Saturn's rings might be. In fact, it was quite understated. It showed a single, tiny point of light, a pale blue dot, almost lost in a scattered sunbeam. This image, known as the pale blue dot, is one of the most profound photographs ever taken. From nearly 6 billion kilometers away, Earth appears as less than a single pixel. It is just a tiny speck suspended in the vast cosmic arena. All of human history has unfolded on that little dot. Every person you have ever known, every hero and villain, every king and peasant, every creator and destroyer of civilization lived their lives there. Every joy and suffering, every belief and ideology, every hunter and forager has existed on that mote of dust, suspended in a sunbeam. It is a humbling perspective that changes how we see ourselves and our place in the universe. The photograph forces us to confront our own significance, or perhaps our lack of it. In the grand scheme of the cosmos, our world is a lonely speck. Let's try to grasp the scale of this image. Voyager 1 was incredibly far away when it took that picture, but in cosmic terms, it was still just in our backyard. Our solar system itself is just a small part of the Milky Way galaxy. Our sun is one of hundreds of billions of stars, each one a potential sun for other planets. Most of these stars are so far away that their light takes thousands or even millions of years to reach us. Now, let's zoom out again. Our Milky Way galaxy is just one among billions of galaxies in the observable universe. Through the Hubble Space Telescope, we have seen images of deep space that show galaxies stretching out in every direction, as far as we can see. Each of these galaxies is an island universe containing its own billions or trillions of stars. The sheer number is mind-boggling. In this cosmic ocean of galaxies, our own Milky Way is just a drop of water. Our planet, our pale blue dot, becomes less than a mote of dust. This perspective can feel overwhelming, even frightening. It can make us feel small and insignificant, but it can also be a source of profound wonder. To think that on one tiny, almost imperceptible world, a unique set of circumstances allowed for the emergence of life. And not just life, but conscious, intelligent life. Life that can build spacecraft, travel to the edge of its solar system, and look back to contemplate its own existence. This is a remarkable, perhaps even miraculous turn of events. The image of the pale blue dot does more than just show us our location in space. It offers a profound lesson in humility. Throughout our history, we have often believed ourselves to be at the center of everything. Ancient civilizations placed Earth at the center of the universe, with the sun, moon, and stars revolving around us. But science has slowly and steadily dismantled this self-centered view. We learned that Earth orbits the sun, that the sun is just an ordinary star in a vast galaxy, and that our galaxy is just one of countless others. The pale blue dot is the ultimate expression of this cosmic demotion. This shift in perspective is crucial for our survival. Our history is filled with conflict, with wars fought over small pieces of territory on this dot. From a distance, our borders are invisible. Our nationalistic prides, our religious and ethnic divisions seem so petty and insignificant. The pale blue dot reminds us that there is nowhere else to go. At least for the foreseeable future, this is it. This is our only sanctuary. We cannot afford to be careless with it. We must be its guardians. To truly appreciate what makes Earth so special, we must first understand its place in the solar system. Our home orbits a star we call the Sun, a rather average, middle-aged star. It is not too large or too small, providing a steady and reliable source of energy. Earth is the third planet from this star, and its location is absolutely critical. Scientists call this region the habitable zone, but it is more famously known as the Goldilocks zone. Just like the porridge in the fairy tale, this zone is not too hot and not too cold. It is just right. If Earth were much closer, like Venus, it would be a scorching inferno. The intense heat from the sun would cause all water to boil away into the atmosphere, creating a runaway greenhouse effect. The planet would become a toxic, hellish world, utterly inhospitable to life. On the other hand, if Earth were much farther away like Mars, it would be a frozen wasteland. The sun's warmth would be too faint to keep water in its liquid state. Any oceans would freeze solid, and the planet would become a cold, desolate desert, locked in a perpetual ice age. The Goldilocks zone is a surprisingly narrow band. Earth just happens to occupy this prime location, a stroke of incredible cosmic luck. Earth's size, for instance, is also just right. It is large enough to have a strong gravitational pull, which allows it to hold on to a substantial atmosphere. This perfect distance allows for a stable climate where water can exist in all three forms: solid ice, liquid water, and gaseous vapor. This dynamic water cycle is the engine of our planet's climate and a fundamental requirement for the complex chemistry that underpins all living things. Let us take a brief tour of our planetary neighbors to see just how different they are from our world. Starting closest to the Sun, we find Mercury. It is a small, rocky world, scarred by countless craters. With almost no atmosphere to speak of, it experiences extreme temperatures. Next, we journey to Venus, Earth's so-called twin because of its similar size and composition. But the similarities end there. Venus is a vision of hell. It is shrouded in a thick, choking atmosphere of carbon dioxide and sulfuric acid clouds. Moving outwards from Earth, we arrive at Mars, the red planet. Mars has captivated human imagination for centuries as a potential abode for life. It is a cold, dusty world with a very thin atmosphere, mostly composed of carbon dioxide. But today, it is a frozen desert. Beyond Mars lie the gas giants, Jupiter and Saturn. These are colossal worlds, with no solid surface to stand on. They are immense balls of hydrogen and helium, with turbulent atmospheres and crushing pressures deep within. While they are beautiful to look at, they are not places where life like ours could exist. Our journey through the solar system does not end with the planets. The giant outer planets are orbited by a fascinating collection of moons, some of which are as large and complex as small planets themselves. For instance, Jupiter's moon Io is the most volcanically active body in the solar system. However, some of these distant moons hold a tantalizing secret beneath their surfaces, hidden oceans of liquid water. Jupiter's moon Europa and Saturn's moon Enceladus are both covered in thick shells of ice, but scientific evidence strongly suggests that beneath these icy crusts lie vast global oceans. Could primitive life forms, similar to those found near hydrothermal vents on Earth's ocean floor, exist in these dark, deep oceans? Even with the potential for subsurface oceans, these icy moons are profoundly different from Earth. Life on our planet is bathed in the energy of the sun. Photosynthesis, the process by which plants convert sunlight into food, forms the base of almost every ecosystem on Earth. Our world's direct access to sunlight is a tremendous advantage. Among all this diversity, only one world we know of has blossomed with the vibrant complexity of life. We have seen that being in the Goldilocks zone is crucial for having liquid water, the solvent of life. But a habitable world needs more than just being at the right temperature. Earth had a head start because it was formed from a nebula rich in heavy elements. Furthermore, Earth's size and mass play a critical role that goes beyond just holding onto an atmosphere. Our planet has a hot, molten core. This internal heat engine drives plate tectonics, the slow, constant movement of the continents across the planet's surface. This geological activity is not just a source of earthquakes and volcanoes, it is a vital planetary recycling system. This process, known as the carbon silicate cycle, acts as a global thermostat, regulating Earth's climate over geological timescales and preventing it from spiraling into a frozen or boiling state like its neighbors. Many rocky planets in the universe may have the right chemical ingredients, but if they are too small, their interiors will cool and solidify too quickly, shutting down this vital life support system. Earth's perfect size keeps its heart beating, constantly renewing its surface and maintaining the long-term stability that life needs to not just emerge, but to thrive and evolve over billions of years. Life is fragile. It needs protection from the harsh realities of space. Earth is equipped with a powerful invisible shield, a global magnetic field. This field is generated by the churning of liquid iron in our planet's outer core, which deflects the most harmful solar radiation away from our planet. Without this magnetic shield, the solar wind would slowly but surely strip away our atmosphere, just as it did on Mars. The beautiful auroras, the northern and southern lights, are a stunning visual reminder of this invisible shield at work. Another crucial element in Earth's story is our unusually large moon. Most planets either have no moons or have small, captured asteroids. Our moon is different. It is thought to have been formed from the debris of a cataclysmic collision between the early Earth and a Mars-sized planet billions of years ago. The moon's gravitational pull acts like a steadying hand, preventing our planet from wobbling too erratically on its axis. This axial stability is what gives us regular, predictable seasons and a relatively stable climate over long periods. Our loyal celestial companion is far more than just a beautiful light in the night sky. It is an essential partner in making Earth a stable and habitable home. Perhaps the most remarkable feature of Earth is something we take for granted with every breath we take: our atmosphere. Earth's early atmosphere was very different from the one we know today. It was likely a toxic mix of carbon dioxide, nitrogen, and water vapor with very little oxygen. About 2.5 billion years ago, tiny microorganisms called cyanobacteria evolved the ability to perform photosynthesis. For millions of years, this oxygen was absorbed by oceans and rocks, but eventually it began to build up in the atmosphere. This event, known as the Great Oxidation Event, was a pivotal moment in our planet's history. The oxygen in our atmosphere does more than just allow us to breathe. High up in the stratosphere, some of it forms into ozone, a molecule made of 3 oxygen atoms. This ozone layer acts as a critical sunscreen for the planet, absorbing the most harmful ultraviolet radiation from the sun. Before the ozone layer formed, life was largely confined to the safety of the oceans, shielded from the intense UV rays. The creation of the ozone shield allowed life to finally colonize the land, leading to the incredible explosion of diversity we see today, from the tallest trees to the largest animals. This brings us to a profound realization. Earth is not just a passive rock that happens to host life. The planet and the life on it have evolved together. Life has fundamentally reshaped the planet's atmosphere, its surface, and its climate. This intricate feedback loop makes Earth a truly living world. The air we breathe is the breath of ancient bacteria. The soil we walk on is enriched by millennia of decaying organisms. This deep connection between the living and non-living parts of our world is perhaps the rarest and most precious quality of all. A dynamic partnership that has created the only paradise we know in the universe. With all the knowledge of how special our own planet is, we naturally look to the stars and ask a profound question: are we alone? For decades, we have been trying to answer this question. We have turned giant radio telescopes towards the heavens, listening for any sign of intelligent life. This endeavor is known as the Search for Extraterrestrial Intelligence, or SETI. The idea is simple. If there are other advanced civilizations out there, they might be using radio waves to communicate, just as we do. Perhaps we could overhear their cosmic conversations or even detect a deliberate beacon, a signal sent out for us to find. The challenge, however, is immense. The universe is incredibly vast and noisy. Our galaxy alone contains hundreds of billions of stars. Where do we even begin to point our telescopes? And what frequency should we listen on? It is like trying to tune into a single radio station when you have billions of channels to choose from. For more than 60 years, astronomers have been patiently scanning the skies, listening for a pattern, a message hidden within the cosmic static. So far, the results of this grand search have been profound in their own way. We have found nothing but silence. The cosmos, as far as we can tell, is quiet. While the search for intelligent signals continues, another, perhaps more fundamental search has yielded incredible results. This is the hunt for planets orbiting other stars, known as exoplanets. In the last few decades, thanks to powerful telescopes like the Kepler Space Telescope, our view of the universe has been completely revolutionized. We have discovered that planets are not rare at all. In fact, they are incredibly common. It seems that almost every star in the night sky has at least one planet. We have found thousands of exoplanets so far. These discoveries have revealed a stunning diversity of worlds, far beyond what we see in our own solar system. Among this incredible planetary zoo, the most exciting discoveries are the planets found within their star's Goldilocks zone. These are the worlds that are at the right distance to potentially have liquid water on their surfaces. Telescopes like Kepler have found dozens of these potentially habitable Earth-sized planets. However, finding a planet in the habitable zone is just the first step. As we have seen, a planet needs so much more to be truly Earth-like. For now, these distant worlds remain tantalizing possibilities. They are pale dots of their own, their secrets waiting to be unlocked by the next generation of even more powerful telescopes. The discovery of so many exoplanets, including many in the habitable zone, makes the silence from the SETI search even more puzzling. This contradiction is famously known as the Fermi paradox, named after the physicist Enrico Fermi, who supposedly asked a simple question over lunch one day: where is everybody? Given the vast number of stars in our galaxy, many of which are billions of years older than our sun, it seems there should have been plenty of time for intelligent life to evolve and spread across the cosmos. The galaxy should be teeming with civilizations, some of them far more advanced than our own, yet we see no evidence of them. There are many possible solutions to this paradox, some hopeful, some terrifying. One possibility is that simple life is common, but the leap to complex, intelligent life is incredibly rare. Another, more sobering idea is what is known as the Great Filter. This theory suggests that there is some barrier or challenge that is extremely difficult for life to overcome. But if the filter is ahead of us, it is a much more chilling thought. It could be a tendency for all advanced civilizations to destroy themselves through war, climate change, or runaway technology. The silence we hear could be the silence of a cosmic graveyard. Ultimately, the Fermi paradox leaves us with no easy answers. Whatever the answer, the paradox underscores the incredible preciousness of our existence. In a silent, seemingly empty universe, our world is a beacon of sound and life, a rare gem of unparalleled value. When we gather all the pieces of our cosmic story, the conclusion becomes breathtakingly clear. Finding another Earth is not just difficult, It is a search for a near impossibility. The chain of events that led to our existence is so long and so specific that it borders on the miraculous. Consider the journey our world has taken. It began with the formation of a star of the right size and stability, our Sun. It required a planet of the right mass, in the right location. Then came the improbable collision that formed our oversized moon, the loyal companion that stabilized our planet's tilt. And then, most remarkably of all, life itself had to begin. That mysterious spark, the transition from complex chemistry to simple biology, is a step so profound that we still do not understand how it happened. It is one of the greatest filters that could make life exceedingly rare, and even after life began, it had to survive. From that oxygenated world, intelligent, conscious beings had to evolve, capable of looking up at the stars and piecing together this extraordinary story. Each step in this long chain is a hurdle. If any one of them had gone differently, we would not be here to wonder about it. Our exploration of the cosmos reveals a fundamental truth. The universe is not designed for life. It is, for the most part, an incredibly hostile place. The vast majority of space is a cold, empty vacuum bathed in deadly radiation. Most planets are either scorched infernos or frozen, barren rocks. Life, it seems, is not the goal. It is a fragile and accidental exception. We are not living in a universe made for us. We are living in the one part of the universe that is fit for us because we evolved here. We are exquisitely adapted to Earth's conditions because we are a product of them. Our planet is not just special. It is a sanctuary. It is a place where the harsh rules of the cosmos have been temporarily held at bay, allowing for something beautiful and complex to emerge. The universe was not made for us, but we have made a home in it on this one pale blue dot. This understanding elevates the value of our world beyond anything we can measure. It is, quite simply, priceless. In the grand cosmic story, our planet is a rare and precious jewel. So, what does it mean for us, humanity, to be living on the universe's rarest gem? It means we carry a profound responsibility. If our world is as rare as the evidence suggests, then it is not just our home. It is a treasure of cosmic significance. The conflicts we wage, the resources we squander, and the damage we inflict upon our planet's delicate systems are not just acts of short-sighted self-harm. They are acts of cosmic vandalism. We are chipping away at the facets of a jewel that can never be replaced. When we drive a species to extinction, we are not just losing an animal or a plant. We are extinguishing a unique evolutionary story that took billions of years to write, a story that may exist nowhere else in the cosmos. The weight of this responsibility is immense. We must act as if this is the only living world, the only sanctuary for life that we will ever know. We are the guardians of an astonishingly precious world. We have been given the gift of consciousness on a planet brimming with life. It is our duty and our greatest privilege to cherish and protect this rare blue jewel. We have journeyed from the edge of our solar system back to our own world, exploring the vast, silent cosmos and the vibrant, living planet we call home. We have learned that Earth is not just a rock in space. It is a masterpiece of cosmic chance, a delicate and intricate system where every part, from its molten core to its loyal moon, plays a vital role. This knowledge should not make us feel small. It should fill us with an overwhelming sense of wonder. This feeling of wonder is a powerful and essential human emotion. Now we can direct that same wonder back towards our own world. We can look at a simple tree, a buzzing bee, or the vast blue ocean, and understand that these are not ordinary things. This new perspective, this deep appreciation, must then transform into action. Our civilization has become a powerful geological force, capable of altering the atmosphere, the oceans, and the very climate of our world. The evidence of our impact is all around us, in the warming temperatures, the melting ice caps, and the loss of biodiversity. We now stand at a critical crossroads. The call to care for our planet is not just an environmental slogan. It is a moral imperative born from our cosmic understanding. When we realize that we are living on what might be the only beacon of life in our galactic neighborhood, the stakes become infinitely higher. Think back to that image of the pale blue dot, a tiny speck of light, so fragile and so alone in the vast cosmic dark. That dot is our home. It is our past, our present, and our only certain future. Every act of kindness, every scientific discovery, every piece of music, and every loving relationship has happened right there. We are not just inhabitants of Earth, we are its guardians. We are the stewards of this precious light in the cosmos, tasked with keeping it from fading out. Working together to protect our home is the most important and unifying mission that humanity has ever faced. Let us embrace our role as guardians with humility, with wisdom, and with a deep love for the rarest gem in the universe. Let us ensure that for generations to come, this pale blue dot remains a brilliant beacon of life. In the grand cosmic story, our planet is a rare and precious jewel, and our future, and the future of this cosmic masterpiece, is in our hands.